Every LLM is a liar, it smiles confidently while making things up. That's not a bug, it's how next token prediction works. A 70 billion parameter model doesn't know anything. It guesses the next most probable word, over and over, and when it's uncertain, it fabricates with absolute conviction. Studies show hallucination rates of 15 to 27% on knowledge-intensive tasks. And even if you fine-tune a model, you can't inject post-cutoff information without catastrophic forgetting. The model doesn't know about events from 5 minutes ago.
Retrieval-Augmented Generation (RAG) is the architecture that turns LLMs from bullshitters into actual reasoning machines that cite sources, handle private data, and answer questions about things that happen today. It shifts the model from knowledge recall to reading comprehension. And once you understand it, you'll never look at a chatbot the same way again. Before we build RAG, we need to understand the 3 fundamental problems it solves, problems that no amount of fine-tuning can fix.
Problem 1: Knowledge cutoffs. Every LLM has a training data cutoff. GPT-4o knows nothing after October 2023. Claude 3.5 stops at April 2024. If you ask about a product launch from last week, the model doesn't know.
And no retraining can fix this. Fine-tuning for facts causes catastrophic forgetting, where the model overwrites its existing knowledge trying to learn new things.
Problem 2: Hallucination. LLMs are next token predictors, not fact databases. When they're uncertain, they guess. And because they're optimized to sound confident, you can't tell when they're making things up.
G et al. 2023 documented hallucination rates of 15 to 27% on knowledge-intensive tasks.
That's 1 in 4 answers being wrong. Problem 3: Private data.
Enterprise documents, internal wikis, proprietary research, none of this is in any training set. You could fine-tune on it, but that costs thousands of dollars, risks overfitting, and needs to be redone every time the data changes.
RAG solves all 3 at once.
It gives the model a knowledge base it can query at runtime, no retraining required.
RAG has 2 phases.
Phase 1 is indexing, you do this once, ahead of time.
Phase 2 is querying, this happens fresh for every user question. Phase 1: Indexing.
You take your documents, PDFs, HTML pages, Notion exports, whatever, and you cut them into smaller pieces called chunks. Then you run each chunk through an embedding model, which converts the text into a dense vector, a list of hundreds of numbers that captures the semantic meaning. These vectors get stored in a vector database alongside the original text and metadata.
Phase 2: Querying. A user asks a question.
You embed that query using the exact same embedding model because they need to live in the same semantic space. Then you search the vector database for the nearest neighbors to the query vector.
These are the K most semantically similar chunks.
You take those chunks, insert them into a prompt template as context, and feed that to the LLM.
The LLM generates its answer grounded in that context. Here's the prompt template, it matters enormously. System: You are a helpful assistant. Answer using only the provided context. If the context doesn't contain the answer, say I don't know. Context: chunk_1, chunk_2. Chunk_k. Question: user_query. Answer.
This instruction, answer only from context, say I don't know otherwise, is what gates hallucination. Without it, the model will happily ignore your carefully retrieved documents and make something up. Chunking is arguably the most consequential and most overlooked hyperparameter in all of RAG. It causes 15% or more swings in recall, more than your choice of embedding model, yet most people just use the default and never think about it.
There are 2 main approaches.
Fixed-size chunking splits text every in characters or tokens, with optional overlap.
It's simple, deterministic, and fast. But it also splits sentences in half, breaks semantic units, and can shove 2 unrelated paragraphs into the same chunk. That's bad. Semantic chunking splits at natural boundaries, paragraph breaks, section headers, topic changes.
You can do this with recursive splitting from LangChain, sentence-aware splitting with Spacy or NLTK, or even LLM-based chunking that understands document structure.
The empirical difference is stark.
Fixed 256 character chunks with no overlap hit about 72% hit rate at 5.
Semantic chunking using spacey-based splitting hits 84%. That's a 12-point swing from chunking alone. LLM-based chunking pushes it to 87%.
Overlap is standard practice. 10 to 20% between chunks improves recall at chunk boundaries for a modest storage cost.
Don't skip it. Embeddings are the backbone of RAG.
They map text into a high-dimensional vector space where similar meanings are close together.
Dog and puppy are nearby. Dog and tax return are far apart.
Most modern embeddings are L2 normalized, which means cosine similarity is the same as a dot product, computationally cheap.
Dimensions range from 384 all the way up to 4096, depending on the model.
Here's what matters practically: all mini LML6v2 from Sentence Transformers is 384 dimensions, completely free, runs on CPU, and scores about 90% of the quality of the best models on the MTB benchmark, the gold standard embedding evaluation across 58 datasets.
It's 50 times faster than a monster model like E5 Mistral 7B.
For most users, it's the right default. For vector search, the algorithm matters more than the database.
Flat search is exact, you compare against every vector, fine for fewer than 10,000 documents.
Beyond that, you need approximate nearest neighbor search.
HNSW, Hierarchical Navigable Small World, is the default in most vector databases.
It builds a graph structure with skipless-like layers that let it zoom in on the nearest neighbors in milliseconds.
It has the best latency recall trade-off in practice. Now here's the critical insight for production: hybrid search beats pure dense retrieval.
Dense vectors capture semantics well, they handle synonyms and related concepts, but they can miss exact keyword matches.
Sparse search using BM25 captures exact terms perfectly but misses synonyms.
Hybrid search combines both scores using reciprocal rank fusion, or RRF.
On domain-specific corpora, hybrid beats pure dense by 5 to 15%. Always use hybrid search in production. Naive vector search gets you surprisingly far, but production systems need more. Two techniques lift retrieval quality significantly: re-ranking and query transformation. Re-ranking is straightforward. Instead of retrieving just your top 5 chunks, retrieve 50.
Then run those 50 through a more accurate model, a cross-encoder that scores each chunk against the query jointly, rather than the bi-encoder approximation you used for initial search.
Keep only the top 5 from the re-ranker.
This improves mean reciprocal rank by 15 to 25%.
It's the single highest ROI addition you can make. Query transformation is the other lever. The raw user query is rarely optimal for retrieval. People say things like, "that thing with the red logo, not great for vector search." So you can have the LLM rewrite the query into a more search-friendly form. Or decompose a complex question into sub-questions, each hitting the database separately.
Or use hypothetical document embeddings, where you generate a hypothetical answer first, embed that, and use it for retrieval. It bridges the gap between short query language and longer document language. There's also a well-documented problem you need to know about: lost in the middle. Liu et al. 2023 showed that LLMs systematically ignore context placed in the middle of the prompt. Performance is good when relevant information is first or last, and it drops sharply in the middle. The fix: always re-rank so your most relevant chunk is first. Simple RAG, retrieve once, generate once, is the foundation. But the field has evolved rapidly, and there are now several advanced patterns worth knowing.
Self-RAG, from Ase et al. 2023, adds reflection tokens.
The LLM outputs special tokens that decide whether to retrieve at all, critique its own retrieved results, and decide whether to generate or retrieve more. It produces more grounded answers with fewer unnecessary retrieval calls.
The catch: it requires a fine-tuned LLM with special training, so you can't use it with off-the-shelf models. Multi-hop RAG handles complex questions that need information from multiple sources.
Instead of one retrieval, the system does iterative retrieval: find something, realize you need more, retrieve again.
Frameworks like Llama Index's Router Retriever and LangChain's multi-hop implement this. It improves multi-hop QA datasets like Hotpot QA by 20 to 40%.
Agentic RAG is where the retriever becomes one tool in a larger agent loop. The agent can decide to retrieve, search the web, run code, synthesize across sources, whatever the task requires. OpenAI's Code Interpreter and Deep Research are examples of this pattern at scale. And GraphRAG, from Microsoft in 2024, builds a knowledge graph from your documents instead of flat chunks. It extracts entities and relationships, creating a graph structure that's far better for multi-hop reasoning and understanding connections between concepts. It's especially valuable for analysis tasks across large document collections, think legal document review or scientific literature analysis. Building a RAG system is one thing. Knowing whether it actually works is another. Here's a practical evaluation strategy in 3 tiers. Tier 1, Retrieval Metrics. Start with recall at 5 and mean reciprocal rank. These are simple to compute, you don't need an LLM at all. Recall at 5 tells you whether a relevant document appeared in your top 5 results. MRR tells you how early the first relevant result appears. These measure whether your retrieval pipeline is working. Tier 2, End-to-end Metrics. Faithfulness checks whether the generated answer actually follows the retrieved context. Hallucination rate counts claims in the answer that aren't supported by the context. These require an LLM as judge, typically GPT-4, evaluating the output against the source documents. RAGAS is the leading open-source framework for this. It combines faithfulness, answer relevance, context precision, and recall into a single evaluation suite, using LLM as judge under the hood. Tier 3, the Golden Test Set. Build 100 to 500 diverse questions covering your domain, each with curated correct documents. This is the single highest ROI evaluation investment you can make. It lets you measure every change, chunking strategy, embedding model, k-value, re-ranking against a consistent baseline. RAG is powerful, but it's not magic. Let's be honest about where it still fails. Chunking is fragile. The wrong chunk size gives you either too much noise or missing context. There's no universal ideal, it depends on your documents. The fix is semantic chunking with document-aware parsers like Unstructured.io or LlamaParse, but this adds complexity. Lost in the middle, we mentioned this earlier, is arguably the biggest unsolved problem in RAG. Liu et al. 2023 showed a systematic performance drop as relevant information moves to middle positions of the context window. Re-ranking helps, but it doesn't fully solve the problem. Latency and cost are real. RAG adds 200 milliseconds to a full second of overhead per query, the embedding call, the vector search, the re-ranking plus API costs for both the embedding model and the LLM. At millions of queries per day, this adds up fast. Stale indices are a maintenance burden. When documents change, you need to rechunk and re-embed them. Without proper versioning and incremental indexing, your knowledge base drifts out of sync with reality. And evaluation is expensive. Human-labeled golden test sets are hard to maintain. LLM as judge evaluation with GPT-4 costs real money at scale. There's no free lunch in quality measurement. So where is RAG headed? Let me give you 4 directions. 1. Long context models. GPT-4 and Claude now handle 128,000 to over 1 million tokens of context. Does this kill RAG? No, because RAG still wins on latency, cost, and precision. Searching a vector database is faster and cheaper than stuffing 1 million tokens into a prompt. The emerging pattern is hybrid, use RAG for targeted retrieval and long context as a fallback for edge cases. 2. Multimodal RAG. We're not just retrieving text anymore. Modern RAG systems retrieve images, diagrams, tables, audio, and video. Multimodal LLMs like GPT-4v and Claude 3.5 Vision consume this visual context natively. Imagine a RAG system that retrieves the exact chart from a financial report along with the text analysis. 3. Edge RAG. On-device embeddings and small quantized LLMs running on your phone or laptop. Privacy-preserving, your documents never leave your device. This is enabled by quantized models, ONNX runtime, Core ML, and Web GPU. RAG on your phone is coming. And 4. Invisible RAG.
The long-term prediction is that the boundaries between retrieval and generation blur until RAG becomes transparent infrastructure.
Embedding models get absorbed into foundation models.
Citations become built-in and automatic. You won't think about RAG, you'll just ask questions and get grounded answers with sources. This is the trajectory from a hot research topic to an invisible infrastructure layer, the mark of a technology that truly matters. Go build a RAG system this week. It's embarrassingly easy to start. Install Chroma, that's pip install Chromab, and try semantic chunking on a document you actually care about. Run a query, check the retrieved chunks, see if the answer makes sense. Then add hybrid search and a re-ranker. That's the stack, no black magic, just thoughtful engineering. Subscribe and comment with what you're building. I read every one, and your use case might be the next video.